Hello everyone, this is Ankush Sharma and today's date is 23 May 2024 and today's my topic is based on core Java and the subtopic is JVM architecture. So we all know that JVM stands for Java Virtual Machine and it is very important for running our program or executing program on any operating system. So let's discuss what is the main architecture behind it and how it just works. Let's go. So JVM, inside the JVM, it contains some parts which works very differently. So it has the class loaders, it has the execution engines, and also it has the areas where the memory gets allocated. Okay, so first we'll discuss the class loader. What is the class loader and how it works behind the runtime method? Like whenever we create the class, so the class loaders will define the class loader first. So the class loader primarily used or the responsible for loading the classes into the memory area and which has the reference for the running program. So whenever we create any class, the class gets loaded into the memory. It has three parts. First is bootstrap class loader, second is extension class loader, and the third one is system class loader, also known as the application class loader. So first we'll dive into the bootstrap class loader, which is the main, the super or the parent class of the all the class loaders. So first one, the bootstrap class loader. It is, so the bootstrap class loader load the rt.jar files class load classes into the memory. It contains java.lang, java.net, java.io, java.sql and java.net, lang, io, util, java.util. This all the package classes loads the class loader and it is the super class of the class loader. Okay, so the second one is the extension class loader, and extension class loader loads the jar files which is allocates in the java home, jre, ext, lib directory. Okay, so also we can say the extension class loader is a child class of the bootstrap class loader, which is the parent class and also the super class of the all the class loaders. Okay, after that the third one and the last one we have the system class loader and the also known as the application class loader. So system class loader, the application class loader loads the files which is in the class path. Okay, so it is also the child class of the extension class loader, and extension also is the child class of the bootstrap. As we all discussed that first one is bootstrap, second one is extension, after that we have the system application. So system class loader loads the classes of the class path directory. This is the child class loader of the extension. So these were the all the class loaders which primarily used for loading all the classes what our program want the classes that loads the loaders. Okay, so after that we have the memory areas. First we'll discuss the memory area and after that we'll get into the executions engine, and after that we also have the native method and also have the counters, PC register counter. So first we'll discuss the areas. So we have the three kind of areas. Okay, first one is method, second one is stack, and after that the heap area. So in the method area, whenever we declare a static variable or the static method, it allocates in the method area. Okay, in method area, whatever like the data or the methods get declared in the static area, they just holds the reference of that data or the address of that data. It does not create any object into it. It just holds the reference and just holds the address of the data, particular data. After that we have the stack area. In stack area, like whenever we declare a variable into the method, which is also known as the local variable, it gets allocated in the stack area, and whenever works get done, it just return and it clears that memory automatically. Okay, we have garbage collector, but it works only into the heap area, not in the stack area. So after that we have the heap memory, which is all the objects are allocated in the heap memory. That is enough for this, because whenever we declaring any object or creating any object, it gets allocated into the heap memory. So these were the memory areas of JVM architecture. After that we have the PC register, which is the program counter register. It contains the addresses or the references of Java virtual machine, which is just being executed by the instructions. After that we have the execution engine. Execution engine means it has the virtual processor, and also it contains the interpreter. Interpreter what works, how interpreter works, it first read the bytecode, after that it execute the instructions. So this is the work of interpreter. After that we have the JIT compiler. JIT compiler stands for just in time. It means it just improve the performance of the program. So like it primarily used for, it compiles the part of the bytecode, it compiles the part of the bytecode which is same functionality at the same time, which has the same functionality of the same time. It just remove that and just reduce the amount of the time needed to the execution. This is the main use for the JIT. And also we have the native method area. So native method area just contain all the native method in the application. So what is the purpose of native method area? Why it is used? Let's discuss. Let's dive into it. So the native method area primarily used for interacting with the system level functionality, which cannot be accessed by the normal Java code. And it is the main purpose is the native method area's main purpose is just improve the performance of our program or our code. So this was my topic today. I hope I clarified this properly. Thank you.